In the heart of the 1960s, a giant metal balloon named Echo was launched into space by NASA, forever changing the course of global communication. Unlike the complex satellites of today, Echo was elegantly simple. It had no electronics, no power source, and no onboard computer. Its sole purpose was to act as a giant passive reflector, bouncing radio signals around the world using its highly reflective surface. This was a radical departure from the existing crazy maze of undersea cables that handled all global communication at the time. Echo's success was monumental, proving that satellite communication was a viable and revolutionary idea. Soon after its launch, President Eisenhower sent a voice message from California to New Jersey, a feat that would have been unimaginable just a few years prior without a network of expensive, cumbersome cables. This simple balloon, with its flawless reflective surface, made the mind-blowing concept of satellite communication a tangible reality. Before Echo's launch, a significant challenge loomed. Some engineers believed that Earth's ionosphere would block any radio waves attempting to pass through it, making satellite communication impossible. To prove the concept, NASA turned to an existing satellite they had: the Moon. In a series of pioneering tests, they successfully used the Moon as a giant reflector to send voice signals from New Jersey to California. This success demonstrated that radio waves could indeed travel to and from space, providing the crucial proof of concept needed for Project Echo to move forward. The principle behind this was simple. Mirroring how light bounces off a mirror, radio waves could also be reflected. As a signal bounces off a surface, it spreads out in all directions, and a small portion of it travels back to Earth to be picked up by a receiver in a different location. A larger reflector would return a stronger, more focused signal, which is why Echo had to be absolutely massive. The construction of Echo 1 was an engineering marvel. It was made from a giant sheet of mylar plastic, a material just 1/10 the thickness of a human hair. This sheet was meticulously cut into over 100 sections, or gores, each covered in a thin layer of aluminum to give the balloon its signature shiny surface. These gores were then carefully glued together to form the final sphere. On Earth, the balloon required a massive 18 tons of air to stay inflated, but in the vacuum of space, only a few kilograms were needed. The biggest challenge was getting this colossal structure into orbit. The solution was to pack it down tightly and then inflate it in space. Instead of carrying its own air supply, the balloon had small canisters of benzoic acid, a powder that transforms directly from a solid into a gas when exposed to heat. Once in orbit, the sun's heat would quickly turn the acid into gas, causing the balloon to inflate fully in a matter of seconds. Once inflated, Echo's immense size made it vulnerable to micrometeorites. To combat small punctures, Echo 1 carried extra supplies of benzoic acid to maintain its pressure. Echo 2, however, had a more robust solution. Its skin was also made of mylar, but it was sandwiched between two sheets of aluminum foil. When the balloon was pressurized, the foil would stretch and harden, making the entire structure rigid and resistant to punctures. Both of these giant, shiny balloons were incredibly visible from Earth, and for an entire decade, they were some of the brightest objects in the night sky, even brighter than the North Star. This brightness was a key feature, as it allowed ground stations to visually track and point their antenna dishes at the balloon as it moved across the sky, which was crucial for sending and receiving signals. Project Echo was not just a communications experiment. It was a groundbreaking scientific mission that yielded unexpected insights. For instance, the balloons were used to accurately measure the size and shape of Earth. At the time, measurements relied on star triangulation and could be off by over 100 kilometers. By using Echo, scientists could form a triangle by measuring the signal travel time from two different locations and the angle the balloon appeared in the sky. With this method, they could calculate the distance between the 2 points to within a few meters, making Earth measurements around 10 times more accurate. Additionally, by tracking how Echo's orbit changed over several years, NASA learned about atmospheric drag and surprisingly, discovered that solar wind was a significant force pushing the balloon towards Earth. Although passive reflector satellites like ECHO never became the standard for global communication, their legacy is monumental. The project proved that a global communication system in space was not only possible, but also a good idea. The receiver used to detect ECHO-S signals was later modified and used to discover the Big Bang, and the materials developed for the balloons are still used in spacecraft today. ECHO-1 and ECHO-2 taught NASA more than they could have ever imagined, and proved that simplicity, when executed with ingenuity, can have a profound impact. These iconic balloons will forever be remembered as the first leap into space communications and as the most beautiful satellites ever made.